So hello everyone, in this video we will try to find an explicit formula to fit given initial term. So suppose we have the sequence 1, -1/4, 1/9, -1/16, 1/25, -1/36, and so on. So how can we find a formula that will generate this sequence? So compared to the previous videos or the previous discussions, what we did was to generate a sequence from a formula. But in this case, from the sequence, we will try to find a formula. Okay, so we can denote the general term of the sequence by a sub k, and suppose that the first term is a sub 1. So we then have 1/1, 1 raised to 2. So we have the first term a sub 1, the second term will be a sub 2, a sub 3, and so on. And we also notice that the denominator of each term is a perfect square. So 1/1 squared is basically 1. 4 is a square of 2. 9 is a square of 3. 16 is a square of 4, and so on. So we can represent it into this equation. And now we see a pattern. So what is changing here? This base, okay? 1, 2, 3, 4, 5, and so on. All right, and we see that these are all perfect squares. So hence, we then have a formula a sub k equals plus or minus 1. Okay, so because we can see that the sequence has an alternating sequence between or an oscillating value between 1 and -1 divided by k squared, right? And since that k is we have a restriction that the integer k is greater than or equal to 1. So we then modify this formula as a sub k equals -1 raised to k plus 1 divided by k squared, wherein the numerator -1 raised to k plus 1 will generate an oscillating sequence 1, -1, 1, -1. So what is the logic behind this? This will result to a positive 1 if k is odd. So suppose k is equal to 1, so that will give us -1 raised to 2, right? So -1 times -1 will result to a positive 1. But if k is even, let's say k is 2, so let's say k is 2, so we have -1 raised to 3. So that will give us -1 times -1 times -1, and it will result to a negative 1. Okay, so basically this explicit formula for the numerator will give us an oscillating value between 1 and -1. So to achieve that oscillation, we insert a factor of -1 raised to k plus 1 or -1 raised to k minus 1 into this formula. Okay, so for when k is odd, k plus 1 is even. Okay, and when k is even, k plus 1 is odd. So consequently, we have this formula then that gives us the first correct term. Okay, note that if instead of starting from 1, and if our sequence begin with a 0, or the first term is a sub 0, it would have led to this alternative formula a sub k equals -1 raised to k divided by k plus 1 raised to 2. Okay, so you can modify if this indeed gives us this correct sequence. Okay,